Welcome, this is Ed Bujak, and we are InnovatiCS, and this is our second session on Introduction to Python as part of our Data Science for Good initiative. So this is only an hour session, so let's move fast. These files will be on the Canvas Learning Management System, and the video for previous sessions are out there also. So this file, this is from the previous session on Python, and the video accompanying it will be in the appropriate place. So real quick, what we viewed yesterday was the introduction to Python, variable naming, conventions, and things like that. We left off on learning about kind of when you put a bunch of integers together, or a bunch of strings together, or a bunch of anything together. How do you get that together? And there's two big concepts you want to understand, and it's sequence data types and collection data types. Sequences are meaning they're in order, and they will preserve the order. And the other ones are collections, so order is not guaranteed, but it is optimized for retrieval, very fast retrieval. So it's not just about collections of 3, 4, 5 things. It's like, what if you have collections of 7 terabytes of something? You don't want to search through it very slowly. You want to have quick access, and they're what we refer to as collection data types, so it makes it easier or quicker to get to. Whereas if you had a list of 7 terabytes of stuff, it's painful. Oh, slow, I meant. It's not painful. The code almost looks the same, but if you know something about what your data is, make it the best data type that encapsulates that idea of the notion of what it really represents. So the list data type, we just went through a small example of animals. And if you have these collections, or these, in this case specifically right now, sequences, they're ordered, give it a plural name. It'll help a lot of people, including yourself, 6 months down the road when you pick it up. So animals is just, here it is, it's a list. Lists are delimited by square brackets because other things have other delimiters. We'll learn shortly. And with any of these multiple collection data types, you can do the length. If it makes sense, you can do math on it. If you have a bunch of numbers, you can do the mean. Mean is the real statistical term, but it's what you normally say is average. So we'll see that today. And we just went into also addressing little elements within these sequences or collections, and we only looked at using integers. So they're called indexes, and the important part is Python starts at 0. So you'll hear things that's 0 based. So some languages are 0 based, some languages are 1 based. So you start counting at 1. Python starts counting at 0. So this is session 2. Welcome, and we're going to enhance what we saw at a previous session because we didn't tell you everything. So we're going to look at some sequences, and the big ones are lists and tuples, and of course they're sequences, so they have order. So what's the big difference between a list and a tuple? A list is what's referred to as mutable. So it stands for mutation. So it can change. So it's mutable. Whereas a tuple is immutable. It's like, well, why do I want something I never change? It happens a lot. Okay? So that's one big difference. Remember, they're both ordered. So There it is. You want immutable for storage efficiency. If you know something's not going to change, and you have a bunch of them, and you know they're not going to change, please make it a tuple. It's faster. Here we go. Oh, and we saw that it was mutable because we changed it in the previous session. We just said we had a list of animals, and we changed one of the elements, and it's like, oh, so it worked. In other words, we were able to change it. Okay? But the thing here is it's called heterogeneous. So the elements in this list do not have to be the same. So I'll just call it I'll just call it stuff, lack of a better name. And remember, I'll write this also. Delimiters are left square bracket and right square bracket. Great. So here it is, and that's an empty list. And it happens to have the name stuff. Well, we got past that, so we're going to make stuff. Have some elements. And you call them elements because it's heterogeneous. They're not necessarily all ints. So you say, well, in some languages you can't have that. It's an integer and a float. So there's a special data type, even in advanced Python, where all the elements have to be the same, which means very fast access and storage is optimized, and you can do a lot of mathematical operations that increase the speed of computation on them if they're all the same data type. I'm talking even if they're all strings, so they don't have to be mathematical operations. Okay, so we saw in the previous session, you can do operations on strings. You got a length of it. What else? You could concatenate strings, like put two strings together. Okay, so what else? Wait, I have an int and I have a float. Well, I'm going to have a string here. Great. And, okay. Watch the way I type this. If I just type something like this, it's black. This is the coloring that this integrated development environment provides for us. And so this is Jupyter Notebook coloring it for us. So you see these numbers, or numerics, tend to be green. Strings or literals tend to be red. And if it's just a variable, you get black. So it's stuff. And that, SFDF, that's a very bad name. So let's have something like this. What if I type TRUE this way? Well, it's black. So that means it's one of your variables. But Python also has a Boolean data type. Very, very used a lot. And we'll see it hopefully today. So it's kind of like the result of, is this number bigger than 5? Well, it's either true or false. Is the name equal to Stevie? Well, the answer is yes or no. So that is what's called a Boolean. Okay, is the sky blue? It's yes or no. So this is called a Boolean. And I'll just run the cell. And it shouldn't yell. So, remember, we saw the previous session that, if you make a mistake, it will yell. So we'll just refresh it, and if we'll just say, we'll put a K there, it'll yell. So, so you say, well, this is some programming language, and a lot of times it's like, hey, it didn't do anything. No, it did something. It allocated a list structure filled with these 4 elements. And I'm going to just say, hey, tell me what this is. That's great. No surprises there. Now, what can you do with it? Well, you can do this. And I'll go 0, 1, 2. I want Harry, so it's 0, 1, 2. Great. Okay. Say not surprised. So this is reinforcement of yesterday. But it's like, well, what about the data type of it? So I'm copying and pasting, so please learn that real fast if you're going to be doing development in the software and programming kind of thing. So I want to say, you know that stuff too? You know this thing right here? Well, Python says, is there a thing called stuff? Yeah, it's a list. So I can do this subscripting, meaning square bracket thing. So you're saying, I want the index, I want to get to the stuff variable. And if you can, get to the element that has index 2. But you can also say, you know, the same thing as above. You're going to say, hey, can I ask for the data type? And it's a string. So we saw that yesterday. The strings are STRs. I mean, the data type is an STR. But what about, I'll do the same thing for that other one, the true-false one, because, you know, we've seen integers and floats. We'll see that. We're going to look about that element in this list with index 3. And it should come back, you know, true. Great. But, you know, what is its data type? And it's a bool. So it's Boolean. No history. I'm not going to tell you why. But we'll see bools when we talk about conditionals, because you'll kind of be using that a lot. Conditionals are it's a requirement to have a programming language. So you have to be able to say, if something something, you know, what do you want to do? And we'll see that. I don't know that today.
Hey, that question.
Yes, great.
Why did it allow you to have a Boolean as one of the value for the stuff? I thought it's going to throw error message.
No, because, well, okay, real quick. A list is heterogeneous, meaning, depending how you say heterogeneous, it's the opposite of homogeneous or homogeneous, like homogenized milk, meaning it's all mixed up. So homogenize is one. It's to homogenize, you make it all one. It doesn't separate. So homogeneous, homo means one, meaning one kind of something. So if it's homogeneous, everything has to be, in the sense of programming, all the data types have to be the same. Are they all ints? Fine. Are they all floats? Fine. Are they all strings? Fine. Are they all booleans? Fine. But lists are heterogeneous. So you see here that that's an int. We didn't check the type. I'm not going to do it. We can check the type of that. That's a float. And we check this one. It's a string. And this is a boolean. So you can have any mixture of, I'm only doing the data types we know so far. You can have a list within a list. You can have a list of a lot of things. Anything, actually. Okay? Now I want to make it just a little bit different. That's a list up there. And you'll see this a lot. And I'll say, first name, okay, animal equal porcupine. Porcupine. Yeah, that's it. Lovely. I got it. I got an animal. And it's like, can I add that animal to that list up there? So when you get a data type, you can do all kind of operations on it, and you could do a lot of functions on it that are provided to you. So what can you do with a list? Well, a real easy one is you could append to it. So it adds to the end. Well, the end is, remember, going from left to right. So the end is after the true, okay? So this is the end. And I just want to append animal, whatever this is. And you say, wait, I don't have to say the actual thing. No, you can actually say, here is a variable. Whatever it is, put that on the end of that other thing. So we say this. We say stuff. So this object-oriented programming, you say, hey, you know stuff. You know that thing called stuff? And Python says, yeah, I'm good with you. I'm a list. And so depending on your development environment, it'll start helping you. So there's two kind of modes that I call it. One is proactive. This is it. It's helping me. It's saying, I know stuff is a list. What can you do with a list? I can do all these things and more. So this is like the proactive development mode, if you want to call it that, where it's going to help you. The other one is sort of a passive. In other words, it's not going to help you unless you ask for it. Okay? And, if I just hit dot, it's helping me too much. I can hit tab right here. Now, I don't know if you heard that, but so tab is used, and people will call it like tab completion. So you hit tab and it'll help you if it knows something about it. Okay, so if I just type S, it doesn't know any. There's no thing called S. I mean, right now. So if it recognizes something, development environment recognizes something about what you've typed so far, it can proactively help you or passively help you. So I'm just going to say, and you can hit append a, and right now the only thing. Okay, these are called functions. They're actually called methods. So the only method that starts with the letter A for lists is append. So okay, and I'll say, what do I want to append? I'll say animal. It's like it didn't do anything. No, just print out stuff now. Well, and there's porcupine on the end of it. So I just wanted to show why you want to start being conscientious of your data types, because different data types can do different things. So you want to make your thing the data type that helps you, that most naturally is what it is in real life. Are you going to be changing it? You want something that you can mutate. Do you care about order? Well, pick the data types that order matters. But you're paying the price, because if you get 5 things, there's nothing going to matter how you do it. But what if it's huge? So you want to start thinking about big stuff, because if you're in data science, data tends to be, you tend to have a lot of data. Okay? I mean a lot. So be careful about your data types. Now, what else can you do? And you say, well, this is great. No, I can't do any math on it. It'll yell. It'll say, I don't know how to do math on strings. That kind of stuff. Meaning math, like, a number. If I say, can you add the number 5 to Harry? And you want to say, I don't even know what that question means. And it'll say that. I can't deal with numbers and strings in the sense of as simple as adding. Or do the mean of them. I can do the mean of 5 and 3.14. But as soon as that string comes in, it's going to throw it off. So it'll have, we saw some errors yesterday, or they're called exceptions. So I want to look at a tuple. And you say, oh, any questions on lists? This is only the tip of the iceberg. Okay. So how's a tuple different than a list? Well, its order is preserved. Yeah, that's true. Okay, nothing different there. Oh, it's immutable. You can't change it. Well, wait, did we just change stuff? Yeah, stuff was 4 elements long. Now it's 5. So we could change. We did change it. Any kind of change. Drops. Oh, there. You can drop an element. You can say drop the second one. Drop the one that says Harry. So you can give it by index, by what the element is. You could insert, and append is very used a lot. You keep adding to the end. Well, what if you wanted to insert after the 3.14? There's an insert and there's a sort and things like that. Ascending, descending, all kind of sorts. Okay. But the moment you insert something, you change it. So to provide that generality, lists are a little slow. Not slow, but compared to these other data types, they're slow. But everyone uses lists because you can do anything to them. It's great. You don't have to think. Okay. So, but remember, the order is preserved. That's important. On a tuple, the order is preserved. It's immutable, meaning you can't change it. It is heterogeneous. But I'm going to just cheat. Sorry for your offense. Immutable. It is immutable. Wait, it is immutable. The delimiters are something else. It is heterogeneous. So the delimiter, I can't spell. I'll fix the other one up later. Delimiter. That's right. Are parentheses. So left. Well, parentheses. They go as sets, right? As pairs. Better not say set. That's coming up. They go in pairs, okay? So let's do a tuple, okay? And I'm just lazy. I'll just say this. Change them to parentheses. What are we going to call this thing? I don't know, I'll call it tup. Please don't name your things int, tup. It's just, I don't know what to call it. And it's kind of quite ridiculous with the example. So how's a 5 and a 3.14 related to this? So you can say things like this. Personal information. So please don't abbreviate like PI. Oh, we all no. Just call it what it is, okay? And I'll just say Harry. And I'm not. Oh, in fact, well, it'll be great because it'll lead to the when we talk about other things down there. Name, age, but how do I know Harry is a name? Okay, age. It's an integer. Most time ages are that. And then 34. Who cares what I type? And what else? Remember, there are different data types. So there's a string. I'm deliberately trying to think of a different data type. So you can say weight. Okay, I'm doing. I'll do height and weight. Height and weight. Height. I'll go 60 inches. Or we'll go 60.60. Okay, 60 inches. So we'll go down only to inch. And the weight will be, 167.3. Just to be difficult. Or whatever it is. Great. I run it. This is great. And I guess I could print it out also. Now see the way it's helping? I only type PER. I don't know anyone who could type it that fast. So I type PER and said, you got 2 things that begin with PER. Okay, I'll take that one. So that's why you want integrated. And you say, great. Okay. A year later, Harry becomes 43. Okay. Oh, well, let's see that we can, since it's ordered, we can use indexes on it. So personal information, we'll look for age. So that's the first element. If that's, hey, good. Wait, I just asked for it. I didn't try to change it. Okay. So that's not changing, that's not testing immutability. So let's try to change it. My 3 keys losing it. Oh, there. I'm going to try to change it. It says you can't do that. A tuple object does not support item assignment. Well, it doesn't support any kind of changing. But it knows what you tried to do is try to change one item or element. So sometimes they're called items, sometimes they're called elements. So a lot of times there's aliases and synonyms. So when you read or ask for help, if it starts talking about elements and you think it's an item, it's the same. Okay, so one item, I have no idea, but that's interesting. Nadim, it's you. Hey Nadim, did you catch that? So I must be sharing something so that when you're moving it around, it drags like a yellow marker behind it.
I think I just accidentally touched the screen and it happened.
Yeah, but how does yours... I don't know how you have control of actually impacting. Not now. Here we go. I hope it's probably on a recording, but hey, is there a way to erase your remarks?
Let me see if I can do that.
Yeah, just don't put more down. I don't know who's doing it. That's interesting. Anyway, here we go. So now we know it's Nadim because when he dragged across, it showed that it said Nadim. Well, the name. So it's just like when you do multiple editing of documents, which is apparently it thinks it has right now. It usually indicates who's making the change. Like if you shared Google Docs, Google Slides, and you're all changing it at once, you'll see everyone's name popping up where they're changing things. It's kind of really nice. So, any questions about this? So, everything you can do to well, not everything. You can't append to a list. That's modifying it. You can't insert in the list. That's modifying it. Like we try to do, we just try to modify. Harry became 1 year older. It's like, oh, that's great, but you got to do it a different way. So you want this deliberately, so that I'm giving you information and I don't want you to change it. It's one of those. That's personal information. Well, I mean, that's what we called it. But you can do other things. You can do anything that doesn't change it. So, hey, give me the length. I forget. It's 1, 2, it's 4? 4, yeah. Oh. Personal information. Oh, too many L's. So it yelled. I didn't do that one on purpose. So it says personal informational L. Was like, well, yeah, right. I don't know. So slippy fingers, fat fingers, all kind of stuff. So, So it is 4. That's great. Now, one thing I'll also tell you about is, it's kind of boring, you only have 4 elements, but you learned about things that have order because we're leaving data types that have order. When you have data types that have order, what if I want more than one? I want more than one of them. Okay? So I want the name and the age. Can I do that? Well, how do I say 0 and 1 at the same time? I want index 0 and index 1 at the same time. Okay? Well, you say, yeah, you do the sub thing. You're saying, hey, personal information, and Python interprets, I'm good with you. I think you're a tuple, so you better not try to do any modifying. Okay, I'm not. And it says, oh, and the square bracket says, I want a piece of it. No, just for reading for now. So you say, I want the 0th one through the first one. So this is called slicing. So it's a beginning, colon, end. And we'll see that again later. That concept of, go start somewhere and go to the end. And, you can go from 0 to 100 in steps of 1. You can also go from 0 to 100 in steps of 5. You can go from 0 to 100 in steps of 3 because you feel like it. So there's actually 3 numbers. We'll see it later. So, and it's kind of not, you can't do much with 4. I can't show you a lot of stuff. So we're going to go from 0 to 1. And we're going to say, hey, Python interpreter, try to give me 0 and 1. And it says, Harry, what? Oh, by the way, so when you slice a tuple, you get a tuple. When you ask for an index, you get one element. Now, also, what if I slice a list? You get a list. You slice something, you get back the same data type. So slicing is starting and ending. You say, wait, I thought you said 0 to 1. Well, this is in most programming languages. You start at 0, so that's inclusive when you start. It's exclusive on when you stop. So it's like as if you went from 0 to 1, but infinitely close to 1, but not 1. So you'll see a lot of, you say, I'll bump this number up by 1. So, 1, 2, 2 now. So you're saying go from 0 to 2 in increments of 1. 0, 1, oh, but not that last one. So there we go. That's called slicing. You can also slice backwards and all kinds of things. Any questions? So indexing is just one integer. Slicing is start, stop, step. Like how much you want to step. So I'll give you a demo of that. Here we go. So by default, if you don't put the step, it's 1. So this is going from 0 to 2 in steps of 1. 0, 1, but not 2. So I'm going to say, do all of them in steps of 2. So it's 0, 2. Oh, I can't get to 4. Okay. So, okay, good. You can see it up here. So it's 0. That's Harry. Then this 60 thing. Height in inches, right? But, it stops there. And it's also default, so you can actually put blanks in there. Not for this session, because there's just too much going on. So you don't have to specify all of them. So you actually see sometimes colon. I don't have to specify start and stop, or I don't have to specify a stride. I don't have to. Yeah. About collections. Collections are data types that are not, the order is not preserved, and it's basically for speed and speed of retrieval. Also, because of the way it stores it. So let's deal with a set. Oh, okay. Order is not preserved, right? So we alluded to it yesterday. In math, the grouping operators, parentheses, square brackets, and curly braces, they're all the same. But in all programming languages, they're different. So parentheses means something. Square brackets mean something different. Curly braces means something different. So a set uses delimiters, of course, something different. Delimiters are curly brace and curly brace. Well, matching, of course. What else? Uniqueness. Meaning elements do not repeat. Can't have the same element twice. So it's like set in math. Really, it's very much mathy. Not that you have to know math for it, but here we go. And I'll just say animals equal. I don't want to demonstrate too much, and I'll make it I'll make it a list because everyone does. When you look for help, tutorials and things like that, almost everyone starts with a list, even though it's not optimal. So here we go. Animals, and we'll say Python. And then we'll say, better not make it P. Sounds like it's something special. So we'll just do all lowercase, just to be consistent. Remember, it's case sensitive, the language Python. So Python with a, aardvark, testing your spelling. Porcupine, elephant. I think I'll take another Python. I think I'll take another Python. No, darn. I'll take another Python. And I'll take a porcupine. I'm trying to spell it the same way. Okay. And it says it. Oh, well, it says it. It didn't yell, so I didn't mess up commas and punctuation and things like that. That's called syntax. So there's animals. Hey, look, the order is preserved. It could be pure luck, but it is. So what can we do with it? Well, remember, the animals. Count. What do you mean count? Yeah, count how many pythons you got. Oh, I gotta put it in quotes. Sorry. Yeah. And he said there's 3. It's like, wow, that's pretty cool. I don't have to write a program to go through that stuff. So that's one feature that a lot of people like about Python. The language Python. I'm sorry. A lot of the minutia is provided for you. In other languages, like very minimalistic in a sense that, oh, I have to write a count routine. I have to write a length routine. I have to write this. I have to write. Python says, no, there's too many people asking for this. We're just going to give it to you because it makes sense. And it helps because, you call your thing something else. The girl down the road called it something else. I call it count. You call it count the elements in a list. And we all have different names. It's like if everyone just says, hey, we're just going to use count. Everyone immediately knows. I know what's going on. I mean, I don't have to write comments in here. Count up the number of pythons in the animals list. I mean, I already know what it says. Well, I have to know a little bit about Python. Great. But I'm trying to get to set. Oh, by the way, porcupines, there'll be 2 of them, and 1 aardvark. And there's also things you can say, hey, you tell me how many unique things you got. And unique things should be Python, aardvark, porcupine, elephant. Right. There's only 4 unique things there. Stop writing that stuff. The Python gives it to you. So let's get back to sets. Let's convert this to a set. You could try to convert any data type to any data type. Most of the time it makes sense. If it makes sense, yes. So if I have a string Harry and I say try to make it an int, it's going to say, where do I even begin? No. I can't make Harry a string. I'm sorry, I cannot make Harry an integer or a float. No, it isn't happening. But if I have a string, 3.14, it's a string with 3.1, and I try to make it in a float, it'll say, no problem. You'll get the number. So you can do math on it. So a lot of the conversion functions or most functions are kind of like a wish. I say that. That's my thing. You give it trash, it's going to fail. Okay, you can't do the square root of a string. Okay. So let's convert it to a set, and I'll just give it a name. It's pretty pathetic. Animals as set. Please don't program like this. This is just for demo purposes, so when you read it, it's like, oh, it's probably the animals, but now it's made into a set. Okay. I just say, hey, make a set of that thing. Make a set of what? So all data types also provide you a function, which its goal is to try to make it what it is. So if you say int of something, it's going to try to make an int of whatever you give it. If you say set of something, it's going to try to make a set of whatever you give it. And animals as set. Oh, there it is. Too many animals now. See, we got like 3 animals now, or 3 animal things. Okay. Anybody see anything crazy?
Yeah, it only put the unique one.
They're not? Okay, what else? Yes, that's what set's supposed to be, and I sort of said that to you. Elements don't repeat. All elements are guaranteed to be unique. Meaning, if you spell elephant two ways, you'll see two elephants, different spelling. So what else do you see about that set? Oh, by the way, what else do you see in that thing?
Curly bracket.
Oh, brilliant. Yes, programmers have to be observant. You can't, if you get tired and you can't think anymore, your programming observation skills will go down the tubes. It's time to go to take a rest. It really is. It'll take you, you'll be programming and, 10 minutes later, it's like, I've been doing the same thing for 10 minutes. Same silly thing for 10 minutes. Well, it's time to just leave, take a break. You don't have to take it.
And one more thing that it has place everything in alphabetical order.
Not necessarily guaranteed.
No?
It's a pure coincidence.
Oh, okay.
But remember, we didn't sort it. So, the order's not preserved. But the order is not guaranteed either. It's stored with a thing called a hash, meaning you'll hear things called hashing function, hash tables, all that kind of stuff. Hashing is real important in computer programming. The hashing function can be ridiculously stupid mathematically. Its goal is to give it something, and it comes back with a number. That tells you something about where you store it. So when you come back and you say, I want one of them, you just run the hash again, and you go to it. You get the hash, and you know exactly where it's at. You don't have to do this searching thing. That was the 1-minute explanation of why you do data types that are fast, if it makes sense. Okay. So, no guarantee on this. Okay. Anybody want to name another animal? We'll put another animal just to see that it's definitely not. Or we'll just try one more, but it's not sorted. It's just a coincidence. So another animal we don't have yet.
Kangaroo. Anything?
Oh, kangaroo from yesterday. Yeah. Okay. Oh, by the way, so the way you decide to print out, well, I'm saying print. If it gets too long, it says you're getting it this way. So, okay, it did wrapping, and once it wraps, it says I'm doing one per line. So when you print out like 500, one per line, it gets a little boring. So be careful what you print. And you say, well, is there still 3 pythons? Sure, I only added kangaroo. Right. Oh, I'm going to leave. It seems to be alphabetical, but no guarantee, okay? Yeah, it's alphabetical. It looks alphabetical, okay? So, and you say, okay, animals in set. Just to show you, it's same as before. You can say, give me the third element. Yes or no? That's porcupine, you would hope, right?
Okay.
No. Order is not guaranteed, so you can't index it. It's just visually displaying it that way. It's not like in any order. So you can't say, give me the third element. Wait, what does that mean? I don't have order, right? Right? If you have a drawer full of pens and pencils, just honest to goodness, just a big bucket full, and you say, give me the third pencil. It's like, I don't know what that means, right? If someone told you, hey, go in that bucket of pencils and give me the third one. I don't even know what that means. But if you say, give me, you can say something like, give me the first red pen you find, maybe, right? But you can't say, give me the third one. They don't have numbers. They don't have indexes, okay? So you can't. This is correct, okay? It's not ordered. Any questions? Now, what's really cool with sets is, you could do, it's really cool. What people do is if you didn't know there was a function that said, can you tell me, here's animals, and it's like 70,000 animals. Can you tell me how many unique animals there are? I'm going to make it a set and then do the length of it. You hear what I said? So here I go. Let's just try that. Just to demonstrate another concept in Python. Someone says, I got this animals thing. I don't know what it is. It's a bunch of them. Just do the set of it. What does that do? That thing comes back with unique elements. Great. Well, whatever that is, can I do the length of it? Sure. So this is like nested math operations. You have to do the first one first, the inner one first. You got to do the set of the animals, and you got this. And you say, yeah, well, it's just still too many. I don't feel like counting them. Also, because I'm lazy or I want to programmatically. I don't want to sit there and do 1, 2, 3, 4. Like, just tell me. It's fine. So the number of unique animals is you say, hey, do the set of it and then do the length of it. So we're capitalizing on a lot of built-in functions because we haven't written one ourselves yet. That's coming up. More.
So is it actually the length or is it the count? You know what I mean?
No. The count is when you're... Don't say count. It's a length. Some people say it's a width. Well, figure out what programming language calls it, and this is called len, meaning it's a length. But the length of what? Oh, the length of unique animals. In other words, so you're saying, take that, whatever it is. It doesn't have to be a list. It could be a lot of weird things. You're going to say, do the set. What does set do? It looks at, in this case, animals, and it comes out with unique animals. Okay. Well, how many? The length of it. Okay.
Okay, so in Python, is there any function called count, or it does not exist?
Yeah, we did counts, but count is well, I'm not going to talk about this stuff right here, but count is saying, hey, look at that thing and count up how many of these you see. So if you say up here, count the number of lions, it's going to come back 0. There's no lion in there in that one.
Right.
So count is counting what you see.
Okay.
Okay. The length is I'm not looking at anything. I'm just doing the 1, 2, 3, 4, 5, 6 thing. Well, actually, starting at 0. So you don't. Oh, you're thinking you're SQL guy, right? SQL calls it count.
Right.
Sorry about that.
Right.
Sorry. Most programming languages call it len or length or something real close to that. They don't use count for length. Okay? No. And I'm sparing a lot of things, but let's talk about dictionary, and that'll be a good break because next session we'll do conditionals and functions. Oh, conditionals and loops, I meant. And real quick, the big view of life. Yeah, there's a paper written in like 1960. They actually mathematically proved that you need 3 things to be a programming language. One is what we're kind of doing, sequencing, like a recipe. Do this, then do this, then do this, then do this. That's a sequence. Or Oh, great. That's one thing you need. You need to be able to have a flow from top to bottom, unless you say otherwise. Well, what do you mean, unless you say otherwise? Well, then you have to have conditionals. That's the second thing you need. So, how does your programming language do conditionals? Yeah, most people say if. Most programming languages use the word if. Great. Third thing you need in a programming language is you got to find some kind of way to loop. I want to do this thing 5 times. Stop taking that code and copying it and copying it and copying it. Because what if someone says do this 10,000 times? You don't do copy and paste whatever I said 10,000 times. And you're probably going to mess it up. You're going to do a little more than 10,000 or a little less than 10,000. It won't be 10,000. So you write loops. So 3 things you really need. Remember, be able to sequence. Second thing, you need to be able to do like conditionals, like if statements. 3 is you need to do some kind of loop or repetition. That's all you need. All the other stuff is extra. But the extra stuff makes your programming language beautiful. So, or hard to use. What's a dictionary? Well, they come in pairs. So, the order's not preserved. So it's definitely, Python is all about dictionaries. I mean, internally. But also, you should use it. And what it does is, it associates 2 things as one element. But then there's the next 2 things as one element. The next 2 things as one element. So some people call it like an associative array. Associative meaning this one is associated with this one. This one is associated with this one. Like a zipper kind of thing. They go together. These 2 links go together. These 2 go together. So let's play with it, and we'll finish. Now I'm going to relate it to something we have up here because it's like this. I'm just going to copy it and paste it down here so we could talk about it. And we'll augment this a bit also. Oh, the delimiters for dictionary. The limiters. Yeah. Are well, we ran out of grouping operators. There's only parentheses, which are tuples. Parentheses, which are, I'm sorry, did I say that right? Parentheses are tuple. Square brackets are lists. And curly braces are right above, sets. It's like, wait, what's going on? It's like we ran out. Dictionaries also use curly braces. But because of what's inside, it knows. But wait, sets only have individual elements. There's only one thing here. There's only one thing here. Whereas dictionaries have pairs. Here you go. Let's do it. That's personal information. Got it. I'll just type it in from scratch, and I'll say, personal, I want to do personal information as a dictionary. I don't feel like saying PID, because Unix guys, you know what a PID is. Personal information dictionary. Personal info dict. Now, sometimes you can abbreviate. Like if it's an identifier, you don't say identifier. Most people just say ID. So certain names are, you kind of go with the, because I don't feel like having a variable, a variable that's 70 characters long is way too, no, everyone will say that's just way too much. And by the way, a variable name length doesn't make it faster or slower. I don't know where that thought ever came from. Not even from day one was it, no. The length of the variable name has no impact on anything. Except human readability. So if you call it P, it's like, what's a P? What's a Q? What's a QQ? It's like after a while you go nuts. So name it what it really is. So personal information, and we'll just call it a dict, okay? Just to emphasize it. So what do you want to do? And they come in curly braces. And I'm going to do this just to show you that you should. I can put everything in one line. It's hard to read. So it's hard for humans to parse it. You mean, when you read it, you're parsing. And you're looking for, well, depending how fast you read, when you first learned how to read, you read 1 character at a time. It was brutal. And then you got to the point where you're saying, I got to be able to read words. So now you're parsing words. And that's pretty much where most people leave it. But fast readers, not just fast readers, but fast readers who read and actually comprehend, they go fast, they parse bigger than words. They don't read 1 word at a time. So what are you pulling apart? So if I give you it all mashed together, it's going to be hard to read. Oh, it'll take longer to read. But if you format it really nice, I know what I'm in. Let's move on. So let's format it really nice. And I'll say, same story. I'll just say, I'm going to not do any fancy stuff. I'm going to do it hard-coded for now, because can I use this in here to form the dictionary? Yeah, but that's like really advanced. So I'm going to say, I got a Harry, I got a 42, I got a 60, and I got a 167. It's like, wait, same as before. But I said they occur in pairs. So here we go. What do you want to call Harry? I think I'll call it a name. I'll call whatever that is. So, let's get the lingo. So they occur in key value pairs. Okay, here we go. So, this is the key, colon, value. So 42 was the age, I'll call it age. Now, so the keys have to be unique. So, yeah, database guys, yeah, you can't have a name and a name. You can't have an age and an age. You can only have one of them, okay? So, keys have to be unique, okay? Age, what is this one? Height. Well, height in inches, okay? So I'll just call it this, height, inches, just in case. It's nice because it'll inform you the units. H-E-I-G-H-E. Not all units, not everything has to have a unit, like percentage. It's dimensionless. H-E-I-G-H-T. Or age. You know, you probably don't have to tell people it's a year, unless it's something strange. Weight, W-I-G-H-T, in pounds, so that's LB. Sorry if you're a metric person, because, yeah. Everyone good so far? Oh, now you see the coloring is weird. Yeah, what's this? Oh, yeah, I forgot a quote there. And a quote there. I'm just going to run it. And it yelled about Harry. Up 2 quotes right here. I'll run it again. So, hey, it worked. Well, it didn't yell. So, we'll just print it out. Oh, I don't know where I got this on thing. Can't spell. And you say, great. Now look the way it looks. When you pull apart these things that have multiple things or collections or sequences, look for the commas. So here don't say the 0th one. It has no order. Just to prove it to you, you're saying, I want to get the 0th thing, so I should come back with name and Harry. Because, right? No, there's no order. Why isn't it? Because it's stored, it's optimized for retrieval. You don't have a key, you don't have a key of 0. What are the keys? Probably 2 minutes left. Personal information dictionary, and say, hey, give me the keys. I can't spell. Now look, it's the keys. So it's name, age, height, weight. Okay. Well, what are the other things called? Well, if they're called keys, the other one's probably called values. Okay. So that's another thing nice about Python. You can almost guess. It's like, well, I've seen it work this way, so I'm going to try it. It'll work. Or, it's really nice. Keys, values. And you can get them together, but not right now. So this is why it's called an associative array. If I gave you an array of name, age, height, weight, pound, whatever, and I gave you another, same length, Harry 42, that you can associate them. You can say name gets Harry, age gets 42, height, inches gets 60, weight, pound gets 1674. Okay? So a dictionary is a collection of elements the elements, since it's a collection, no order is guaranteed. So name key does not occur before the age key. Well, that's definitely not in order. So this one's not showing up in order, right? It's not alphabetical, right? The keys are not alphabetical. And so a dictionary is a collection, unordered, of key value pairs. And it says there's no key of 0. That is true. The keys are name, age, height, inch, weight, pound. You can only talk to those things. So I said, give me 0. So like, wait, you mean you can talk to name? You can talk to age? You can talk to height, inch? Yeah, let's talk to that. And I didn't say, oh, it is mutable. So you can change things, and we'll change it, and we'll stop. I don't know where I'm typing. Mutable, 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 mutable. Now the question is, what's mutable? In the sense of a dictionary. We'll show you only one thing, so we can respect the time here, and we'll pick it up next session. You can't modify everything all the time. Okay, personal information dict, or whatever that's called. Great. Well, you say, oh, wait, that looks like you're talking to it like it's subscripting. Yes, but you subscript with it by the name of the key. So if I say, give me, like I did before, give me key 0. You could have a key 0, but we don't. We only have key of name, age, height, and weight. So let's talk to height in inches. I like single quotes, but remember, single quotes and double quotes don't matter. So I want to say height. What's the problem? And you'll get this key error a lot. It's like in a lot of places. Behind the scenes is a dictionary. So what's wrong with this? It is a classic when you just get out of your seat and you talk to your friends like, you dummy.
The name is incorrect. Height_in.
Exactly. It's a classic. And if you stare at this thing for too long, just get up and leave and come back 3 minutes later. It's like, oh, it's obvious. It's height_in inches. Okay, but or you can just bug your friends and they want to hit you, and it's like, you dummy. It's called height in, and it says great. It's 60, and you say so. It's just like a variable. You're saying go to this data structure and give me the value at that variable. So you're saying, hey, your dictionary? Subscript. Don't say subscript when it comes to a dictionary, but so you're saying get the key that looks like this. And absolutely last thing. Sorry. If you don't like that, you can kind of do this kind of thing, but it has restrictions on it. Oh, no, you can't. I'll take that back. That's something else. So we're going to stop now. Oh, one more thing. I swear, it's like I keep saying. We're going to modify it. So we're going to change it from 60 to, he gained a few, what is that, inches. He gained an inch. He grew. Oh, he's big. He's, no, 60 is short. That's 5 feet. You're short. So you gained an inch for some reason. Or you can actually shrink. Maybe you're getting older and people tend to shrink a little. But not like 2 inches. It's a little bit or bigger. So your spine compresses. It does. And when you sleep, your spine expands. So when you wake up, you're taller than when you go to sleep. Just read about it. It's kind of neat. So, and I'm going to print it out, and then we're done. Personal information dict. And you see, the height is now 51. Oh, 51 is like, you're a child. That's real short. Sorry, I messed up. But you can see I can modify it. So you can modify the variables. The values, Sorry, you can modify the values in the dictionary. And that's what most people do a lot. They say, I got some information. I don't know where you're storing the height, but can you change it? Yeah. Or you can also say, take whatever the height is and add 1 to it. You can do math on it too. You can say, Take what you got there, add 1, and put it back. So don't fear math. Don't fear the dictionary. It's pervasive. So we'll stop now.